In this video, I'm going to give a update on the TinyScaleLab project. I have finished doing my quick and dirty training runs, and so now I have a good sense of which models to run on which GPUs and approximately how much it will cost and how much time it'll take. So my goal was to get rough but reasonable estimates of training time and costs using the two GPUs that I can run that can handle flash attention 2, which is the L4 and the A100 GPUs on Google Colab Pro. So the model architectures are as follows. I think I'm for now settling on 4 model sizes: 5 million, 25 million, 60 million, and 125 million. I'm using the hidden dimension and intermediate dimension from the Tiny Stories 1 million, 8 million, 28 million, and 33 million models. And I'm using 8 attention heads for now for all models. And I'm using the Llama 2 tokenizer with a 32,000 vocab size. So this is what my models look like. The smallest model has a 64 hidden dimension, and then it goes up to 768 for the 125 million. And then the intermediate dimension, I've followed the Tiny Stories models where MLP layers have a 4 times the hidden dimension value for the intermediate dimension. And then the number of layers are more arbitrary. I just picked whatever number of layers that gave me close to these relatively set of diverse model ranges. So just under 5 million, just under 25 million, a little farther from 60 million than I would like, so maybe I can bump this up to 7. I don't think so. I think it went past 62. And I guess a pet peeve of mine is I don't like it when the model names are less than the actual number of parameters, so I would rather err on the side of underestimating or overestimating with the model name and having fewer parameters. And then we have close to 125 million. So the training data set includes 4.9 million stories. This is from the Tiny Stories dataset. They have a tar file which contains stories from GPT 3.5 and GPT 4. I'm using the Llama 2 tokenizer, and this comes out to a little over 1 billion tokens, so about 1.03 billion tokens in the entire dataset. The training details are pretty arbitrary for now. I mean, I guess I shouldn't say arbitrary. I'm using what worked for Tiny Hackathon, but I haven't really modified anything else from that. So I'm using the Hugging Face trainer with data collator with flattening, which is their sequence packing implementation. I'm using a 5e-neg4 learning rate for all models, a weight decay of 0.1, and a warm-up of 5,000 steps. I'm training for just one epoch. And then I'm using the L4 GPU for the 2 small models and the A100 GPU for all models, because I want to get a sense of when is the A100 actually more efficient and cheaper than the L4. And here are the training results. So what I've highlighted here is the lowest cost for model size. So for the 5 million parameter model, it took just under an hour. I had a batch size of 384, which only used 20% max memory, and the cost was about 20 cents, and really speeding up. So something I could experiment with, but at least for now, this is a nice rough estimate. The 5 million parameter model on the A100 was actually 7 cents more expensive, because even though I could get a much larger batch size and I was using more of the GPU, the time savings was not as significant, because I was getting about a third of the time in terms of savings, and the A100 costs a little more than 3 times. It's like 3.5, 3.6, 3.7 times the cost for an L4 in terms of compute units. So another, just interesting relationship between batch size, time, max memory, and cost. So 5 million parameter, I'm going to stick with the L4. The 25 million parameter model, I was using the A100 with a much larger batch size than my L4. I was using 98% of memory, so I probably need to lower the batch size a bit. And I was saving about 3 cents per epoch. So in a let's say it takes a, 40, 50 epoch run, I would save, a couple dollars on that. So not really a big deal. I think, for the 25 million, I might go either way with the L4 or the A100. Then for 60 million and 125 million, I only tried that on the A100 because I was noticing that here the batch size was, the memory was already kind of maxing out. So for the 60 million parameter model, one epoch costs 40 cents. And for the 125 million epoch, 125 million model, the single epoch costs 84 cents. And I'll probably have to reduce the batch size because I don't want to flirt with out of memory, and it was using 99%. So this gives me a rough estimate. I'm sure if I tweaked the batch sizes, then maybe I could eke out a little more efficiency in the cost. But from this point forward, once I train, let's say the 60 million parameter model, let's say I train it for 20 epochs, which is what I did in my tiny hackathon. And the 5 million parameter model is 12 times smaller, so maybe I have to train it for 80 epochs. I don't know. So I'm going to start doing these more longer experiments eventually. And once I do that, I'm going to get a better sense of what this full training cost looks like for each model. And then I can kind of scale up how many training runs I need to do in these experiments. And then I have a better sense of what my budget will look like. So what are my next steps? So I'm actually going to pause on training for a little bit, and I'm going to switch to setting up some eval infrastructure. So I'm going to first start by figuring out how I can use Gemini Flash 2.5 or Claude Haiku 3.5 as an LLM judge. So I'm going to generate stories using the already published tiny story models. And so the 1 million, 8 million, 28 million, and 33 million parameter models in that increasing order should give me increasingly better stories and in terms of scores. I'm going to manually evaluate maybe 100 stories or 200 stories and then use the LLM judge and then do a comparison and then iterate on the prompt that I'm giving it. And eventually I would like to get, 80-90% match between my scores and the LLM judge scores before I would feel comfortable implementing this eval infrastructure in my training pipeline. Once that's at a good place, I will set up a callback. I haven't done something like this with Hugging Face before, / weights and biases, so I got to figure out what that looks like, so that'll probably take a few days. And then once that's set up, I'll train the 60 million parameter model, which is the model I've already trained for 10 epochs and 20 epochs, and I've gotten decent results. I'll train that with the eval logging and make sure that I'm getting, reasonable results as that training progresses. And intermediately, I will, check the prompts and check the scores and make sure it at least makes sense and looks good. So just a quick recap on where we're heading with this project. There's two things that I want to study individually and combine. I want to study training dynamics of these tiny models. That will come later in phase 2. Right now I'm focused on getting eval set up to measure language capabilities. So I have 3 categories of capabilities: foundational language capabilities of grammar and context tracking, emergent capabilities of factual knowledge, reasoning, and creativity, and story-related capabilities, which is the plot. So these are the 6 categories that I'm going to use for scoring with my LLM judge, as well as my manual scoring as I improve the prompts to get my LLM judge scores to match what I think are reasonable scores for the different prompts generated with the existing published Tiny Stories models. So that's an update, hoping that I can give another update tomorrow. I try to break these steps down into smaller steps and give frequent updates because it really helps me to write this down and talk through this in these videos, and it really helps my problem solving process. So thank you for watching, and I will see you next time.